Replacement reactions. Now, like I said, they're a little bit harder because now you have to decide which ones do we have. We have replacement, we have composition, we have decomposition. It's a little bit harder to do that. Replacement reactions are going to look like this. General formula is going to be A plus BX yields AX plus B, or, take a look at this one, AX plus Y yields AY plus X. In both cases, somebody's being replaced. In the case of the first reaction, it's the positive ion, or the first element in the compound is being replaced. In the case of the second one, it's the negative ion, or the second element being replaced. And both of those, by the way, you should all have in front of you right now your common ion sheets, because we're going to be referring to those in a second. Now let me illustrate a very simple replacement reaction. And we're going to go, like I did the other day, in order on your sheets. Okay, things are not going to always be as simple as you think. All right, so you kind of have a look at the sheet and figure it out. If you look at the sheet, there's 4 different replacements, and underneath those replacements, there's actually A, B's, and C's in some of them. So here's my first one: aluminum plus copper 2 chloride yields. And I'm going to demonstrate that one by illustrating to you. By the way, write small, because you're going to have to fit all of this. It's going to get harder and harder to fit these on one line. Do not, if you're past halfway for your arrow, you're not going to have room to fit the rest of this over here, right? So write small. Maybe even start over, beyond the margin line, like I did there. Okay? Now, I can illustrate this by illustrating my prodigious strength. You ready? Coke can. I like Coke. Hate Pepsi. Pepsi. He's on Coke. Okay, you ready? I'm not on Coke. Wait. Now I'm on Coke. I was standing on Coke. All right, check this out. I'd have to be on Coke to do this, or at least meth. All right. You ready? Watch. Wow. Put that light on. You see that in slow-mo. I'm going to rewind that later and play it in slow-mo. Wow. That's pretty amazing. How did I do that? Well, I am strong, and I don't wear short-sleeve shirts just so I don't, scare anybody. But it's also why I wear a beard. If you look at this closely, I actually tampered with the evidence here. All right, I'll show this up here close to this thing. If you look real close too, you'll see there's actually inside there a little bit of brown around the edges of where that's cut. All right, and here's what I did: a regular soda can. It's basically, you say, well, it's aluminum, right? That's why this is aluminum plus copper 2 chloride. Well, a regular soda can isn't just aluminum. There's a thin plastic layer over and inside of the aluminum. Very thin, micro-thin plastic layer. What I did was, I used, your triangular files in your drawers? I stuck it inside of here, and I scraped it out on the inside only. So you couldn't really see the scratches very much. So I scraped off the paint on the inside. And then I filled it up with copper 2 chloride solution, which is a blue solution. Remember that copper sulfate we used? That would have worked too. Remember that copper sulfate powder? It was blue when we added it to water and we added stuff, it all fizzed. Remember that lab and the percent composition lab? Percentage. We sucked the copper out. Remember that one? Yeah. It was a blue solution we were stirring up there. Remember? Same thing. I poured that inside my can, and it ate away wherever it touched the aluminum. Because what did I get? You can turn that light off now. What will aluminum plus copper 2 chloride give me? Figure it out. What do you think? It's common sense replacement reaction. Again, you have to be able to apply a generic formula to a specific example. Which one do you think this is going to apply to? What do you think I'm going to get from the other side? You have to be thinking. You can't wait. See, this is the part of the problem that most of you guys have. The reason, if in a class that was actually able to think, which if I gave you enough time, you'd eventually figure it out. But if you weren't just waiting, you guys in high school level are at the point where you're waiting to be told what to spit back to the teacher. If I'm in a college class, I would hope at least by that point, I'd be anticipating what the teacher's going to say next. If you're anticipating what he's going to say next, what do you think I'm going to get over here? What do you think? Aluminum chloride. Exactly. Aluminum plus copper 2 chloride is going to yield aluminum chloride plus copper 2. In other words, these two guys are going to replace each other. Exactly right. Exactly right. Because it is a replacement reaction, as I kind of hinted at in the beginning. And that brown stuff on the inside of this is copper. Remember that copper that floated to the bottom of the beaker when we did that lab? I asked you, what's that brown stuff? You said rust. Remember that? I said, no, it's not rust. It's copper. The whole point of the lab, I had told you, was sucking the copper out of copper 2 sulfate. Here, it's copper 2 chloride. That aluminum got completely replaced. So it no longer was holding the can together. You know what's holding the can together before I ripped it apart? The paint. And it wasn't very hard for me to rip it apart. That's why I was able to do that. All right? Well, that's the first step. That's the hardest step. I know you don't believe that. You think balancing's the hardest step. It's not. It's also worth the least points, balancing. Hardest step is figuring out what kind of reaction I have and completing it. Once you've done that, all I have to do now is treat this. And I'm always amazed by this. I did the first worksheet. I'm going to give that back to you today. You, because you have a single today, are going to actually have homework tonight with a worksheet. Normally we do the worksheets in class. You won't have time to do that because I want to give that test this week before Christmas, especially if we have a chance of a snow day tomorrow. I definitely don't want to take that chance of having to put this off till after Christmas. So I have 1 day of leeway. If I had to push it to Friday, I could. But if we get a snow day tomorrow, I would have to do that. So you have some homework tonight. Rest of this problem is just writing the correct formulas underneath. Let's do that if the thing's working now. Aluminum, oh, I'm still on green. Aluminum correctly written as Al. Everybody agree with that? It's not Al plus 3. I don't look at the charge. He hasn't combined with anybody yet. Copper is, however, combined with chlorine. Copper 2 would be copper with a plus 2 charge, Cl with a minus 1 charge, CuCl2, right? And guys, as you do these, you simply look at each formula with blinders on. I don't care what's over there or what's over here. I'm writing aluminum chloride correctly. So I write Al, and I write his charge. What's the charge of aluminum? Plus 3. He's in group 3. Everybody see it? What about Cl? What's his charge? Yeah, he's in group 7. He's minus 1. He wants to gain 1 electron, correct? I got plus 3, I got minus 1. Why did I say to look at this with blinders on? I could care less what's over there. I couldn't care less what's over there. Al's got a plus 3, he's got a minus 1. It's AlCl3. People who don't do that, people who don't look with blinders on, guess what they write for that Cl there? They write a 2. Well, so we had a 2 over here. Don't have to balance them? No. You do not balance the reaction by writing the wrong subscript. You balance it after you've written all the compounds correctly. Copper by himself is just Cu. Now I can balance the equation. So if I do that whole step right, I can only lose 1 point. These are going to be worth, on average, about 8 points apiece. On average, 8 points apiece. 1 of those points is for this last step. You've got 7 out of the 8 points right now. What's the only thing left to do? Well, I've got 2 chlorines and I've got 3 chlorines. That's a problem. I'll have to put what in front of this guy? Exactly, and in front of this guy? Hey, can I just put it in between him? Can I put the 3 right there? That would make it easier. I wouldn't have to change the copper that way. No. It has to go in front of the entire compound. I don't break a compound up. You see that, right? All right. Now, I did mess a lot of other things up when I did that. I messed up my aluminums. I needed 2 there. And I messed up my coppers. I needed 3 there.
Kind of looks like a B.
What's that? Kind of looks like a B. Yes, it does. Right there. All right. But it's not, and we know that. Okay. Let's do the next one. Now, I don't want you to call this number 2 for a reason. Trust me on this. You're going to see in a minute why I didn't want you to do this. Do not call this number 2. Just write this down underneath the last one. Silver plus calcium nitrate.
That's my cat's name.
What's that?
Silver.
Silver calcium nitrate.
Yep. Come here, calcium nitrate.
Okay.
No, it's silver.
It's silver.
Calcium nitrate.
Okay.
She's so cute.
It is cute, yes. Now, don't finish this one on your own. This is one time I don't want you to anticipate because you'll be wrong. Okay, I normally like you to anticipate. I want you at this point, because I didn't do it, but Marie's into this today. So Marie, read replacement reaction. You said to read out loud, number 1.
Okay. Replacement of a metal by a more active metal.
You all see that? Right. And that worked out perfectly for number 1 here. Aluminum replaced copper. You know why? Because aluminum is more active than copper. Okay? I want you to know what happens to this guy. You know what happens to this guy? Absolutely nothing. A big, fat X. And here's why. Silver cannot replace calcium. He's not more active than him. He's not better than him. How are you supposed to know this? Am I going to make you memorize it? No. Look at the bottom third of the sheet. Look at the bottom third of the sheet. That's the activity series. Let's apply the activity series to this first one up here we just did. Is aluminum better than copper? Is he higher than copper? Y'all see where aluminum is? You're looking at the activity series on the bottom third of your common ion sheet. If you don't have them with you, you can't be doing this. You're not going to get it from any other place. Aluminum's higher up than copper, isn't he? Okay, so that works. Is silver higher up than calcium? No, so he can't do it. It's kind of like this, okay? Let's just say, Marie, give me a famous supermodel.
Oh wait.
Female, male, whatever you want.
Tyra Banks.
Tyra Banks. Okay, we can use Tyra Banks. I don't know who that is, but okay. I was thinking more along the lines of Kate Upton. She's big now, right? Kate Upton. Jennifer who? Lawrence? Jennifer Lawrence. Yeah, she's in the Hunger Games. All right, okay. Let's just say one of these supermodels, all right, is, in this case, going out with Anthony. Okay? So they're a couple. They're a couple, all right? Now, along comes Tom Brady, from the Patriots. Not Tony Romo, because he sucked it up last night. But Tom Brady comes along, right? Tom Brady comes along. Anthony's going out with Kate Upton or Tyra Banks. Okay? Tom Brady starts. They did lose. You're right. They lost. But, he's still got that other supermodel. What's the supermodel he's married to? Giselle somebody, right? There you go. Michael's got it down. He knows what he's talking about. All right. Now, along comes Tom Brady. And Anthony's at the club with his girl and his peeps. And he's hanging out with Tyra Banks or whoever. And Tom Brady comes out and starts hitting on her. It's not unlikely that she might just ditch Anthony for Tom Brady. It's possible. I think it's probably very likely. Now, on the other hand, let's say Anthony gets himself into the club where Tom Brady and Giselle, what's her name again, Mike? Man, he's good. And those two are, Tom Brady and his wife are hanging out. This is Tom Brady. That's his wife. Here's Anthony. Anthony is not going to replace Tom Brady. He's not strong enough to replace Tom Brady. I don't know. They snuck in somehow. Not sure. All right. So you got the idea? You got to check the activity series. This guy, can he replace that guy? In this case, he can't. He's Anthony. All right. So you can't replace him. All right. Let's do another one. Let's try this guy. That's the one we just did the demo for. It won't be on camera. Sorry, people at home. But we did do that one in the fume hood because it was kind of dangerous.
Sodium plus water.
Sodium plus water yields. Now, you're going to have to look because you know what I get for this is one of the worst answers in the world?
Salt water.
Sodium water, yeah. Sodium plus water yields sodium water. There's no such thing as sodium water. Look at your common ion sheet. Find him on there. What do you think sodium plus water is going to yield? There's three possibilities. Because if we read number 2, Caitlin, read number 2.
Replacement of hydrogen and water by some metals. Yeah,
replacement of hydrogen and water by some metals, but then there's A, B, and C underneath that. You see it? So, what do you think this guy's going to give me if I have sodium plus water here? Hannah?
It's a very active metal.
Right, so what will I get? Sodium plus water will yield what? Read the rest of that, figure it out. Apply the general to the specific. Read A. What does A say you're going to get?
Metallic hydroxides.
No. Metallic what? Not hydroxides.
Yeah.
Metallic hydroxides plus?
Hydrogen.
So what will I write up here? Everyone is doing this in their head too. What will I write up here? Sodium plus water. A very active metal plus water is going to yield what? Specifically, what's it going to yield?
Sodium.
Hydroxide plus hydrogen. See, you apply the generic to the specific. The generic's on your sheet. You don't have to memorize these. I'm telling you what they do. You simply have to apply whatever metal I give you to that case. And by the way, how many other guys would have done this? Only a few other ones. They're in parentheses there, right? You see them? You see the guys I'm talking about that would have done this? Potassium, right? You see that? Who else would have done this? Lithium. So if I was, look here, if that were lithium plus water, it would have said lithium hydroxide plus hydrogen, right? Okay, now let's write everybody underneath it. Na for sodium. We all know water is H2O. Sodium hydroxide is Na with a +1, OH with a -1, and hydrogen is H, right? No. What did I do wrong? Hydrogen is diatomic. He gets a 2 next to him when he's by himself. Well, why don't I put a 2 next to him right here? Because he's not by himself, right? Here I have to use whatever the charges of the ions are. Now this one is a particularly weird one to balance. Can you figure out, who can figure out how to balance this guy? Everybody take a chance, take a second to try this one. It's a little weird. The NAs are okay. The O's are okay. But my hydrogens are weird because I've got 2 on this side, but I've got 2 and 1, 3 on that side, and they're split up. So I'm not going to just find a least common multiple in this case. I'm going to turn this guy into an even number that I can balance. What number will I put here, Anthony?
2.
2. That will give me a total of how many H's on that side? 4. Now I can balance water. Now I can balance the H's with a 2 in front of that guy, right? But he messed other things up. He messed my O's up, right? So, I'm sorry, over here he messed my sodiums up. And so what do I need over here? 2. All right.
Sodium water.
Right. And if you write sodium water, you're getting no points. It has to be sodium hydroxide plus hydrogen. All right. Now, I have a neat little thing about this guy. You might ask yourself, before I go on to the next example, what would happen if you had a large amount of sodium? You saw already what happened if he took a big chunk of it and he threw it in that beaker in that movie, right? I'm talking about a really large amount, okay? I'm talking about like a barrel full. Wouldn't that be kind of fun? Well, actually, we'll see. I have a little video of what happens when you do that. It's from 1940s, but it's still a cool video. You can turn the light off for me, please.
What, were you in your like 20s then?
Yeah, I was like, I was pushing these barrels off myself, actually. 1947. That's me, Ben. That was my name back then. Changed it.
Back in
Hey, why is there any sound? There should be sound.
Don't do it.
Wait, there should be sound. Let me make sure there's sound inside. Okay. Why? I thought there was sound for this one too.
47, I don't think there is.
Dangerous metallic sodium head for destruction in Lake Lenore, Washington. The government surplus chemical ignites and explodes when wet.
Those are
The
barrels
alkali
of
lake
sodium.
is devoid of fish and forms an admirable disposal spot. A 3,500-pound container of sodium hurtles into the lake and crashes through a foot of ice. As the water seeps in, smoke rises through a series of muffled explosions.
What's going up there is the hydrogen.
The acrid clouds billow several thousand feet over the steep sides of the lake. Disposal of the chemical by the War Assets Administration is made necessary because no public carrier will accept it for transportation to a purchaser. One after another, with varying effects, the containers go up with spectacular results as water and sodium meet.
Now, I'm going to go on to the next one. Here's my next question. That's with a large amount of sodium. What about, let's put the light on for a second. Look at the periodic table. Look at potassium. Is potassium more or less powerful, better metal or worse metal than sodium? Remember my rules? Remember? He's better, right? You're further down in the group. So potassium would react even more strongly than sodium. Check this out. Turn that light off. This is why you should never do the sodium or the potassium.
So potassium metal is very reactive.
And yes, this guy looks like he swallowed some, and that's what I did to his hair. But besides that, take a look at what happens.
One of my colleagues who used to work with it described it as evil.
Oh, see, you don't get any chance. You don't get any second chance.
So we've come out behind the chemistry department in the open air to try and do a retake of the potassium video. The last sample of potassium was very, very small, maybe 500 milligrams.
It will react so reactive that if you have it in a box with argon so that it can't get oxygen from anywhere, it will take the oxygen out of paper, which is paper is a compound of carbon, hydrogen, oxygen, and it can extract this.
It's a reactive element. It's used in our body all the time. We have lots of potassium floating around, and we've got some samples here, about a gram, maybe a gram and a half of each.
It's a pretty big chunk of potassium, this.
Ready?
Yeah.
Very satisfying reaction.
Okay, so even those strong metals, like very active metals like potassium, sodium, lithium, those guys are going to react very quickly. All right, but now I want to do some less active metals. Take a look at this guy, magnesium. I'll do this demo too. I've done already the can, with aluminum plus copper. I did the sodium one in the fume hood. And now let's do one taking a little bit of magnesium. We've used magnesium before. I'll use them again. Take a look here. And this guy, put him in here. I'll take a little water. And I put him in there. And here's my magnesium. Turn that light on for me for a second. Okay, so there's my water. I'll move this up nice and close so you can see it, hopefully. That's pretty good. Maybe a little higher. And you can all see, hopefully, too. And I'm going to just add a piece of magnesium. Now, we've used magnesium before. Right? It's the same stuff we've used in probably about 3 different labs already, right? Let me rip this guy up, and I'll throw a piece into the water. A couple of pieces, actually. Well, I'm not running away from this guy, right? I mean, the first one I did in the fume hood. The second one was too dangerous to show you. I just showed you the video of it. This is magnesium, all right? Well, we can look at it in a little bit, and we may see a few little tiny bubbles on there, but that's about it, all right? It's reacting, and you will see it react. You'll see it actually react better when I'm going to add something to this and make it react better in a little bit. But as you can see, it doesn't react anywhere near as fast or as well. All right, so move that out of the way. And let's do the reaction for it. All right, hit the light off for me. What do you think magnesium plus water gives me? And no, the answer is not magnesium hydroxide. Because you look at your sheet. What does it give me? Magnesium oxide plus hydrogen. Now, it's still going to give me hydrogen, but it's going to give me magnesium oxide. Now, I want you to finish this one on your own, all right? Okay, and I'll come back and finish it in a second. But try that one on your own. See, make sure you know what you're doing.
Hey. Oh, he's kicking my shit, yeah. Kicking my shit. Shake.
Y'all done? Finish that one up? You're getting better at these. It doesn't take as long to do them. I would hope by now. Let's take a look. Did you get magnesium is Mg, water, of course, is H2O, Mg plus 2, O minus 2, and then hydrogen is diatomic and H2.
It's done.
And that's another beauty about this one. I purposely wanted you to see again. Not all the ones you do on the tests or on the worksheets even have to be balanced. One of the other reasons why balancing is your least important thing. Okay? Can you complete the equation, identify the equation, and write the correct formulas for all of them? That's what I'm looking for in this. Okay. All right. There's 2B or not to be. That is the question. All right. What's next? What does 2C say? Uh-oh.
I got this. Metal is less active than iron. Cannot react with water.
Yep. How do I know that? What am I doing right now? Describe for the people at home.
Washing your hands.
Not quite. I'm running water over my hand. What's on my hand?
Iron.
Put the light on.
A ring.
Yes, someone was stupid enough to marry me. What's it made out of? Iron. Yes, I'm a dwarf. I got married with an iron ring. No, I'm not a dwarf. I'm not from The Hobbit. What do you think the ring's made out of? Gold.
Plastic. At least.
Plastic, right. Gumball machine. No, it's a gold ring. And why don't I have to take this off before I go swimming or taking a shower?
It doesn't have.
Because if you look where gold is on that sheet at the very bottom. Yeah. You know, one of the reasons gold is so precious and so worth so much money. Turn that light off for me again. Is that my precious? So precious. Worth so much money is very simple. Gold doesn't react with anything, or at least not very easily. All right, it's very unreactive. So I could put gold with water. You know, the best part about gold, you know, if the gold goes down in a ship, you know, a Spanish galleon from a couple hundred years ago, sitting at the bottom of the ocean, and they dig up that gold, what's it going to look like? It's going to look like gold. Yeah. If you dig up, you think the iron that was on there is going to the pistol that was in there is going to look like the pistol? No, it's going to have rusted. But gold doesn't react with water, and so that's one of the reasons why we like it. It's great for use for currency. It's great to use for a lot of things because it doesn't ever really change. All right. So there's my reaction of a very unreactive metal. All right. You can hold on one second. You need to do this for homework. Yeah, that's we do for all you guys tomorrow when I hand this out to you. All right. Let's go on. So by the way, have you noticed we have X's popping up now? Another reason why these are harder than the composition and the decomposition one. We have to worry. Do these even work? We have to worry about that. All right. Let's look at another one. Take a look. Magnesium plus hydrochloric acid. We'll do that one right now.
No.
Okay. Magnesium plus hydrochloric acid yields. Now again, if you look at your common ion sheet, you could absolutely figure this one out very easily. The problem would be with this one is you may not, I told you didn't have to know what acids were. The one acid you have to know is hydrochloric acid. We've used it in at least 4 labs, I think, this year, maybe 5 or 6. I'm not sure exactly, but I know we've used it at least 4. Does anybody remember the formula for hydrochloric acid?
HCl.
It's just HCl. Yeah. Now, that will make my life a lot easier when I go to finish this problem. But let me show. I said I'm going to show you a demo of almost everything today. Here we go. Take a look at this one. Put this guy back up here. Remember my magnesium from before? If I look at him very closely now, I will see tiny bubbles on him. Very tiny. Okay? And they don't really amount to very much. However, I'm going to dump out that water, and I'll pour some acid in. It's okay. All right. Now, can we see that one? I don't know. Let's see that. It's still not high enough, really. One more book. One more book. There. I think you can see it now. Turn the light on so you can see it better too. Let me pour a little acid in here now. You can see this is the guy I'm talking about here. Pretty cool. All right, I'll add some acid in. And we'll put the top on back. There you go. Now, scared the crap out of me. Scare you? It scared Anthony. You never put a stopper on something that's giving a gas off. See, he's reacting a lot faster now. All right, he's giving off, obviously, again, hydrogen gas, and he formed something else. And we'll talk about what that is so you can figure that out. But he reacted a lot quicker than was just water, right? That's the reaction of magnesium with hydrochloric acid. Can you tell me what it forms over here? Turn the light off again. All right. Well, here's what I'll get for a terrible answer. Probably Brendan was going to say it. Magnesium acid plus hydrochloric. No. I really would be much better served to do this on this one. I'd be much better served to actually write this guy out first down here. And then it will be obvious what happens. Here's Mg, right? And you all said it's the only acid you have to know. Hydrochloric acid is HCl. We're going to learn how to name and write acids in a future chapter. Now, when I write it like that, does that make it a little bit easier to see what's going to happen here? What do you think's going to happen here? What do you think I'm going to get on the other side? I'm going to get magnesium is going to replace the hydrogen, right? So what will I get over here? Magnesium chloride. That's magnesium chloride plus hydrogen. Now, of course, I will have people who will do that, and it will be wrong still. No, it's wrong for another reason, too. Yes, I do need H2. I did not write magnesium chloride right, and I know I get some people like that. I have to use the charges when I write compounds. Mg's got a +2. Cl has a -1. And it's MgCl2. Now I need to balance this guy with a, I hope you all see it, 1 Mg, he's okay. 1 H, 2 H's, I'll put a 2 in front of him. 2 chlorines, he's all good. You got it? I know the bell's going to ring right now, but I got to pass those worksheets out for you and give you your old ones too.
Let's see.